Hi, today we're going to be learning the basics of trigonometry. Trigonometry is basically the math behind triangles and using many different formulas to find out missing components such as angles and sides of these triangles. So what you see here may be a mess, but I'll kind of walk you through it and you'll realize that trigonometry is not as overwhelming as it may sound. So to start off, let's look at the triangle and let's look at the basics components of this triangle. In a trigonometry problem, we'll always be given a right triangle. So using the right triangle, we can deduce that there's always going to be a hypotenuse, which is the side opposite to the right angle. We're also going to be given a kind of special angle called theta. So theta can change based on whatever problem it is, and theta is what we use in reference to our trigonometric functions. So we also use theta to find out all the other sides of the triangle. In reference to theta, the opposite side is always the side opposite to theta. The hypotenuse, as we stated earlier, is the side opposite to the right angle, and the adjacent side is the side that touches the starting of theta. So that might seem kind of a weird description, but essentially it's the side that's neither opposite to theta or the hypotenuse. So using that information, we can put that into three trigonometric functions. The first one is the sine of theta equals the opposite over the hypotenuse. And the next one is the cosine of theta equals adjacent over hypotenuse, and the tan of theta equals the opposite over adjacent. Now that might seem kind of hard to memorize, but using this acronym using that acronym SOHCAHTOA, we can kind of memorize it a little easier. So for example, SO stands for sine is opposite over the hypotenuse. So instead of memorizing all of that, if you just memorize what each letter stands for, memorizing SOHCAHTOA will be an easier way to remember all the trigonometric functions. Now, all of these are always in reference to theta, as the sine of theta, for example, the sine of theta is the opposite over hypotenuse, right? So we always look at what our theta is and where it is. And in this case, it's over here. So the opposite is this side and the hypotenuse is that side. For example, if theta comes over here and changes, the opposite side actually changes to here, as the opposite side is only the side opposite to theta. And once theta changes, the opposite changes as well. And the adjacent changes along with it. So the adjacent would be this side, as the new opposite side is over here. The hypotenuse side would always stay the same because it's always across the right angle. Now, how do we put this into a problem? For example, let's look at the first problem here. We're given the angle theta, which is 30 degrees, and we're also given a side 10 meters. We have to solve for x, which is in this case the hypotenuse. We could also deduce that 10 meters is right opposite to theta, hence it is the opposite side of the triangle. So we're given using SO, which is SOH, we found out that this would be a sine problem, as we're given an opposite and we're kind of given a hypotenuse that we're trying to solve for. So with that information, we use this trigonometric function. We kind of sub in all of the variables. So sine of theta, which is the first part, so sine of 30, which is theta, equals 10, which is the opposite, over x, which is the hypotenuse. Using algebra, we isolate x as the hypotenuse, and then we can solve for x. Just punching this into the calculator, 10 divided by sine of 30 would give us the side of the hypotenuse. Now, the calculator always needs to be in degrees mode, so basically Once you open the calculator, you press the mode button and you click degrees. And that's when you just punch in the equation into the calculator. So let's look at the next problem. The next problem, we're given an angle, which this is actually 10 degrees. My handwriting's kind of messy, excuse me. And we're also given x, which is the adjacent side of theta. And we're also given 16 as a hypotenuse. In this case, we're trying to solve for x. So since we've identified that this is the adjacent side, as we're not given an opposite side, we're given the hypotenuse, that this would be a cosine problem. So setting that up. So we set up cosine of 10 equals x adjacent over 16 hypotenuse. Now using algebra again, we can isolate x by multiplying 16 by both sides. This gives us 16 cosine 10. Now using that, we have found the adjacent side. So just plugging this into the calculator would give us the value of the adjacent side. So overall, today was a lot of information basically on the parts of the triangle and how they could be applied into problems, and using just a simple rearrangement of equations, we could find out many different components of the triangles.